Okay, so somewhat similar question to the last one, but we've got some things that are a little bit different. So start with my car, horizontal road, slightly smaller trailer, but doesn't really need to be to size. And we've got 680 kilograms here for the car, and we've got a smaller 350 kilograms for the trailer. Put my tow bar in between and split my object down the middle. Again, at this point we're still ignoring vertical forces on things that are moving horizontally. We will come to look at the vertical forces on things moving horizontally when we're asked to calculate things like friction more accurately in the year 13 part of the content. So it says the car starts to brake. So driving force is always driving it along. Braking force is going to be kind of inhibiting that movement. And then we've got what is known as thrust. Okay, so if you imagine the tension, it's effectively pulling that one along and inhibiting that one. Okay, so pulling it back some way. Thrust kind of works the other way. It is kind of pushing into, cars pushing into that object, and the thrust is kind of driving the object behind into this car. So the difference is that the directions just are the other way around, effectively. Okay, if you don't pick up on that, or it doesn't say it's thrust, then you will still get the same answer if you do it as you would normally do for tension, which is going towards each other. It'll just be negative, and at that point you might figure that out. What's kind of gone wrong there. I'm still going to take my positive direction going to the right because the object is still moving to the right, and the acceleration will be negative 4.6 meters per second squared. I'll talk about why and how and stuff in terms of the negatives in a minute, but I think for me it's what I say. If it's moving to the right, I'd rather do it to the right. So first of all, we're going to be doing 3F equals ma again. A is F equals ma, so I'm going to the right. So first of all on the car, then on the trailer, and then finally on the whole system, if relevant. And we wouldn't necessarily sit down and do all these three every time we did a question in the exam, but it might just help you, especially when you're starting out, to try and figure out what's going on. So the car has got a thrust force, so it's kind of braking, and this trailer is kind of being jammed into it. So we've got tension minus braking force is equal to 680 times by minus 4.6. The trailer has got a negative T. So again, it's got the car kind of jamming into it, effectively with this bar, and that equals to, that's the trailer, so 350 is its mass, times by negative 4.6. And the whole system, the two thrusts are effectively going to cancel, so we'll just have a negative braking force equals the combined masses, which is 1030 times by negative 4.6. And then for what we're asked for, which is the thrust, it looks like this one here is going to be the most useful. So negative thrust is going to equal to, negative T is going to equal to negative 1610 newtons. So the thrust is going to be 1,610 newtons. And that's our answer. If you want to check it, you could always work out something like the B. So again, and you could even kind of, like I could do there, kind of realize the negatives are going to cancel out. And if I cancel them out on this one, I'd get 1030 times 4.6. So I get a braking force of 4738, and I could use them both in that first question. So I could do 1610 take away 4738, and that should equal to the value I need to on the right hand side. Oopsie. 680 times 4.6, or negative 4.6, and it does. So I've checked it in that top one as well. My calculator, it does seem to work. So just with thrust, you've got to be a little bit careful and think about the actual impact it's going to have when a car is braking like that.